In this video, I will show you how to use the magnetic force expression for a single charge to think about forces that are acting in entire current carrying wires. So this is one wire, it's not connected right now to anything though. So I'm gonna be using my drawing. Let's say this is the wire and I have my electrons moving to the right. This is their velocity, and let's say somehow I was able to create a magnetic field in this direction. And this is the magnetic field, I have the same magnetic field everywhere here, and of course I do have more electrons moving around, I'm just not showing them. So here is another electron moving, here is another electron moving, and so on. I don't need really to worry about this because whatever I do here with this electron, I'm gonna get the same result for this as well. So thinking about the direction of the magnetic force for one electron will work. Now, I see to find the direction of the magnetic force, the first thing I need to do is use my right hand and place my fingers in the direction of the first vector and then curl them in the direction of the second vector. So since the velocity of the charges are pointing this way, I'm gonna do this. And then I will curl my fingers in the direction of B, that's the second vector. And then I know that my thumb, which points up towards U out of the page, is giving me the direction of V cross B. So here V cross B goes out of the page. Now the thing is, I also need to think about what is the charge, the sign of the charge Q. Because this is an electron, it has a negative charge, so this vector that points out of the page with a minus sign in front means that the magnetic force goes into the page. So if I have the wire and if I have the electrons here moving to the right, if my electrons are moving this way, then the magnetic force is going to be pushing on the wire downwards. Now, if I do one more example, let's say in the direction of B. I'm gonna keep the electrons moving in the same direction. So if magnetic QBB, I'm gonna continue to allow the electrons to move to the right. But now I'm gonna have the magnetic field pointing down. I wanna see what happens if B points into the page. So the vector, okay, here is my artifact. This is my B vector. And to find the direction of the magnetic force, I need to start with V cross B. As before, I need to use my right hand, the fingers of my right hand, and have them point in the direction of V. Now, because B points into the page, I cannot really do something like this. I have to rotate my hand so towards V, and then I curl my fingers in the direction of B, and my thumb now goes this way. So this is the direction of V cross B. I do recommend that you try this, that you practice and see if you get the same thing that I did. So if V cross B goes this way, and this is a negative charge, so I have the minus sign, this means that the magnetic force will point this way. In other words, if the magnetic field here goes down into the page and I have the wire, I should see, if the force is large enough, I should see the wire doing this. I should see the wire moving in that direction. If the magnetic force is large enough to see this effect, that's what you will see.